Okay, I think we can wait for 30 seconds. Okay, I think we can start. Uh, Firstly, hi. In the previous lesson, we learned how a four-stroke internal combustion engine works step by step. We studied the four main stages of the engine cycle. Uh, there was intake, compression, power, and exhaust. You can see in here. We also saw how these states repeat continuously to produce motion and how different engine parts work together during this process. Okay, now we will understand how a four-stroke engine works, uh, and now we can take the next step and look at another type of engine. In this lesson, we are going to compare two important engine types, two-stroke engine and four-stroke engines. Even though both types of engines work based on similar principles, they are not the same. They have different designs, different working cycles, and different advantages and disadvantages. I will talk about more deeply. Some engines are designed to be simple and lightweight, like two-stroke, and others are designed to be more efficient and controlled, like four-stroke engines. Because of these differences, engineers choose different engine types depending on the application. For example, some vehicles or machines need more power in a short time, uh, but others need better fuel efficiency and long-term performance. So we can't say best engine type. There is no single best engine type. Each type is suitable for different purposes. In this lesson, firstly we will understand the basic idea of two-stroke engines. Then I will review the four-stroke engine. After that, we will compare these two systems in terms of working principle, efficiency, power, and usage. At the end of this lesson, you will understand the differences between two-stroke and four-stroke engines and why both types are still used today. Okay, I think now we can start with two-stroke engine. Two-stroke engine is a type of internal combustion engine uh, that completes a full working cycle in only two piston movements. This is the main difference between a two-stroke engine and four-stroke engine. In a four-stroke engine, the piston needs four movements to complete a cycle, but in a two-stroke engine, the same process is completed in only two movements. Because of this, the two-stroke engine works faster and produces more power. Okay, now I will talk about stroke mean. A stroke is the movement of the piston inside the cylinder. When the piston moves up, that is one stroke. When it moves down, that is another stroke. So in a two-stroke engine, you can understand this. The piston moves up and down once to complete a full cycle. This means that every rotation of the crankshaft produces power. Now let's look at how this engine works in a simple way. In a two-stroke engine, the intake, compression, power and exhaust process happen in a, how can I say, combined way, not in the separate steps like in a four-stroke engine. During the first stroke, the piston moves upward. At this moment, the air-fuel mixture inside the cylinder is compressed. At the same time, a new mixture uh, enters the crankcase below the piston. Then comes the second stroke. The spark plug ignites the compressed mixture. This creates combustion and push the piston downward. As the piston moves down, it also helps push the how can I say, fresh mixture from the crankcase into the cylinder. At the same time, exhaust gases leave the cylinder. So in a two-stroke engine, multiple processes happen at the same time. This makes engine simpler and faster. Okay, I think it's enough. Now we can talk about another important differences between two-stroke and four-stroke. A two-stroke engine doesn't use valves like a four-stroke. You can see valves in here. Uh, it uses ports. You can see here. Ports are openings in the cylinder wall that allow air and fuel to enter and exhaust gas to leave. These ports open and close automatically as the piston moves. This makes the system simpler because there are fewer moving parts. But in the four-stroke, we have more moving parts. Okay, now let's think about the advantages of a two-stroke engine. First, like I said, it is simple in design. It has fewer parts, so it is easier to build and maintain. And the second, it is lightweight. Because of its simple structure, it is usually smaller and lighter than a four-stroke engine. And third, it produces power, more power. Uh, Since it produces power every cycle, it can deliver higher power compared to its size. Because of these advantages, two-stroke engines are used in small machines. For example, they are commonly used in motorcycles and small equipment. However, two-stroke engines also have some disadvantages. They are less fuel efficient. This is because some of the fuel can escape during the process because it doesn't use valves. Like I said, the fuel can escape during the process. They also produce more pollution because combustion isn't as controlled as in four-stroke engines. Additionally, they can wear out faster due to less lubrication and higher operation speeds. So even though two-stroke engines are simple and powerful, they are not always the best choice for all applications. I think that's enough. Now I will summarize what we learned for two-stroke. A two-stroke engine completes a full cycle in two piston movements. It combines multiple processes into fewer steps. It uses ports instead of valves. It is simple, lightweight and powerful, but we have some disadvantages: less efficient and more polluting. In the next part of the lesson, I will compare two-stroke and four-stroke engines in more detail to understand their differences clearly. But before this, uh, I want to review for you. Okay, um, a four-stroke engine is a type of internal combustion engine that completes its working cycle in four separate piston movements. Each movement is called a stroke, and together they form a complete cycle. Uh, these four strokes are intake, compression, power, and exhaust. Each stroke has a specific function, and all of them must happen in the correct order for the engine to work properly. This is so important, correct order. During the intake stroke, the piston moves downward and the intake valve opens. Uh, this allows the air-fuel mixture to enter the cylinder. During the compression stroke, the piston moves upward and both valves are closed. This compresses the mixture, increasing its pressure and making it ready for combustion. And during the power stroke, the spark plug ignites the compressed mixture. This creates an explosion that pushes the piston downward and produces motion. Uh, this is the only stage, how can I say, where the engine actually generates power, produce power. During the exhaust stroke, the piston moves upward again and the exhaust valves open. Uh, this allows the burned gas to leave cylinder. By the way, I want to give extra information. When our all valves are closed, uh, we call sente in Turkish this situation. And while two valves are open, when the exhaust gas finish parts and intake part, intake stroke, intake strokes first part, we call subap bindirmesi in Turkish. Okay, uh, after this, after the exhaust part, the cycle repeats from the beginning. One important difference between a four-stroke engine and two-stroke engine, sorry, is that the four-stroke engine produces power once every two cycles of piston movements. Because of this, it works in a more controlled and efficient way. Another important point is that four-stroke engines use valves and camshaft to control timing. You can see valves in here. This makes the system more complex, but also more efficient and more cleaner. Okay, now we are ready to compare the two-stroke and four-stroke engines in detail. Now I will compare two-stroke and four-stroke engines in detail. Both of these engines are internal combustion engine and both convert fuel into motion. However, they work in different ways and have different characteristics, like I said before. Understanding these differences is very important because it helps us, how can I say, see why different engines are used in different situations. Firstly, I want to talk about working principle. A two-stroke engine completes a full cycle in only two piston movements. This means that intake, compression, power and exhaust process happened in a combined way. On the other hand, a four-stroke engine. A four-stroke engine completes the same cycle in four separate strokes. Each stage happens in independently and in a more controlled manner. Because of this, the two-stroke engine works faster, but the four-stroke engine works more systematically, works slower than two-stroke. Okay, now power output. A two-stroke engine produces power in every cycle. This means that for every rotation of the crankshaft, power is generated. Because of this, two-stroke engines can produce more power compared to their size. But a four-stroke engine produces power once every 2 cycles. This means power production is less than two-stroke. However, the power is smoother and more controlled. So we can say that two-stroke engines are more powerful for their size, but four-stroke engines provide smoother performance. Now I will talk about efficiency. Four-stroke engines are more fuel efficient. This is because the combustion process is more controlled and less fuel is wasted. Uh, but in the two-stroke, some fuel can escape from ports. In two-stroke engines, some of the fuel, uh, especially during the intake and exhaust stroke, the fuel can escape, like I said. Because of this, two-stroke engines consume more fuel. So in conclusion, we can say if efficiency is important, four-stroke engines are the better choice. But if you say efficiency is not important for me, you can use two-stroke engines. Now, complexity. The two-stroke engines have a simpler design. You can see in here. They don't use valves or complex timing systems. They use ports that open and close with piston movements. Because of this, they have fewer parts and are easier to build and repair. But in four-stroke engines are more complex. They use valves, camshafts, and timing systems. This makes them more complicated but also more precise and efficient. Now, another difference is weight and size. Two-stroke engines are generally lighter and smaller. You can see in here. This makes them suitable for portable machines and small vehicles. But four-stroke engines are usually heavier and larger because of their more complex structure. Okay, another differences. 1 minute. Okay, maintenance. Two-stroke engines are easier to maintain because they have fewer parts. They but and they can wear out faster because they operate at higher speeds and have less effective lubrication. Four-stroke engines are more durable. They are designed for long-term use and have better lubrication systems. Even though they are more complex, they usually last longer. Okay, now the important point, environmental impact. Two-stroke engines produce more pollution. This is because combustion is less controlled in the two-stroke, and some fuel isn't burned completely. They can escape from ports during the process. But in the four-stroke engines, they are cleaner. They burn fuel more efficiently and produce fewer emissions. That is why four-stroke engines are more commonly used today, especially in cars. Because if you use two-stroke, uh, we can pollute the environment. Now, I want to talk about application areas. Two-stroke engines are used in small machines. uh, because they are lightweight design. They have lightweight design. For example, small motorcycles and small equipment, lawn equipment. Four-stroke engines are used in larger and more complex systems. For example, cars, trucks, bus, and generators. This shows that each engine types is used for different purposes. Because of that, like I said at the beginning part, we don't have the best engine. We have different engine for purposes. Now, advantage and disadvantage. Uh, Two-stroke engine, the disadvantage: simple design, lightweight, high power for size. But we have disadvantage too: less efficient, more fuel consumption, more pollution, and shorter lifespan. And four-stroke engine advantage: more efficient, cleaner operation, longer lifespan, and smoother performance. And I think enough for four-stroke. And disadvantage: more complex, heavier, and more expensive than two-stroke. Okay, I think that's enough for comparison. Uh, I will summarize this. There is no perfect engine. Each engine type has its own advantage and disadvantage. Two-stroke engines are better when simplicity, lightweight design, and high power are needed. Four-stroke engines are better when efficiency, durability, and environmental performance are important. So engineers choose the engine type based on the needs of the application. It's changing to application. Okay, I want to talk about what we learned in this lesson. Today, we compared two important types of internal combustion engines, two-stroke and four-stroke. We learned that both engines are designed to convert fuel into motion, but they do this is in different ways. The two-stroke engine completes its cycle in two piston movements, but the four-stroke engine completes the same process in four separate stages: intake, compression, power, and exhaust. Because of this difference, two-stroke engines are simpler, lighter, and can produce power more uh, frequently. However, they are less efficient and produce more pollution. And four-stroke engines are more complex, but they are more efficient, cleaner, and more durable. We also saw that these differences affect where each engine type is used. Four-stroke engines are usually found in smaller machines. Uh, if you say lightweight design are important, you can use two-stroke. Four-stroke engines are more common in larger systems like cars and trucks. Uh, like I said, if you want more power, more performance, and long-term use, you can use four-stroke. And one of the most important ideas in this lesson is that there is no perfect engine. Each type has its own advantage and disadvantage. The choice of engine depends on the needs of the application, so engineers must decide which engine is more suitable based on factors like power, efficiency, size, and cost. Okay, understanding these differences, we now have a clearer picture of how engine design affects performance and usage. Okay, I think that's all for this lesson. In the next lesson, we can explore more advanced topics or look at common engine problems and their solutions. Uh, that's all. Thank you for listening. Goodbye.